So in today's lesson, we're looking at keys to solving very simple equations. If you can master this part of the lesson, you can master almost any equation that's given to you in the future. You have your papers to follow along, and we're starting on this first page that says solve by adding and subtracting. You need to be able to explain the steps to solving an equation. I say that because there's going to be a few things that you see today that you may have already seen before. First thing we need to do is define what is an equation. So go ahead and write this in. An equation is an expression set equal to another expression. So that says an equation is an expression set equal to another expression. All right? It could look something like this. An equation could be 2x plus 4, an expression set equal to another expression. How about 27 minus x? Those are two different expressions. In the center of it is an equal sign. They're equal to each other. Almost as if on this scale, the middle was an equal sign, the expression on one side always has to remain in equal balance to the expression on the other side. And so we'll see how we keep those things in balance as we go along. Now the next vocabulary here is the solution of the equation. This one is very simple. The solution of the equation is the answer after solving. I say after solving because there's a few key things we have to do in order to solve for the equation. The main goal of the equation here is to isolate the variable. Remember, the variable is the x, the y, the b, the q, whatever that letter is that is holding the place for the number that's unknown at this time. And I put this graphic here because to isolate means we want to get it all alone. If you notice, I put this creepy graphic, like a thing behind bars. I call it, we want to get that variable behind bars isolated in confinement all by itself. So you would have your variable here, let's say it's an x, equal to all the stuff that we're going to shuffle around, which is what we'll be learning today. So your x, or variable, on the scale would be equal to some solution right here. Okay? If you have all that, what we're doing is moving on to the next screen. So, like I said, there's going to be a variable on one side of the equation. Please underline, it does not matter what side the variable is on. Sometimes it may be on the left and it may be x equals a bunch of stuff. Or it may be a bunch of stuff equals x. Both ways are perfectly acceptable. What we do when we're shuffling things around, we undo or cancel out. That's the terminology you use. And so remember, you do the opposite of whatever the operation already is. Well, what do you mean? Well, for an example, if you see a negative 10, the opposite would be a positive 10. So minus 10's opposite is plus 10, written underneath. So for an example, a positive 7, the opposite would be a negative 7. Or I would call this plus 7 minus 7. There's another way you could see this written. You could see just a 2 with the variable x stuck to it. This means 2 times the letter x, number x. Now, is this positive or is this negative? The way to tell is look in front. If there's no negative sign, you can assume that it's positive. The opposite of this is negative 2x. Even though on these I saw the plus in front of it, when I don't see a plus in front of it, you always assume it to be positive. So the same with over here, if I had a minus 2x, the opposite of minus 2x is 2x. Notice I didn't say plus 2x, I just said 2x because 2x is already positive in itself. These are a few examples of the opposites. In order to undo or cancel out, we have to remember to do the opposite of what we already see. On the next screen, I want to read this to you, and I'm going to ask you to underline a few things. When you complete equations, it is required that you justify your steps along the way. So please underline justify your steps. This is the part that separates high school from middle school, and it's not very hard. You already are doing the steps in your head. Now you have to explain, circle the word explain, to someone else what you are doing. This is how to show you truly know the material. The end of course exams will test you in many ways. You cannot just memorize what the problems should look like. You are going to be required to actually understand the problems. So let's figure it out and let's get some practice. So I'm going to go to the next slide. How do we justify the steps? Well, first of all, look at my example. It says x plus 7 equals 9. Put a check mark in that box if you're able to solve that easily. If you already think you know the answer, put a check mark in that box. What number would be a good number that you could fill in here that when you add 7 would equal to 9? I say the number 2, because 2 plus 7 is 9. So I would put a check mark there that I don't have to do a bunch of algebra to know my answer is 2. However, we do have to go through and walk through the steps using the simple problem first so that you can fully understand the steps on a hard problem. So what I do first is I rewrite the problem. This way we can start fresh, and that's always step number 1 is rewrite the problem. So I rewrote x plus 7 equals 9. And the step was rewrite the problem. Here I have 2 columns available. A column where I'm going to do the work, and then a column where I'm going to write the steps. So do you remember when I said you have to undo or cancel out by doing the opposite? And do you remember where I said we want to isolate the variable and get it by itself? Because I'm isolating the variable, I'm going to put a box around that x. That means I'm locking him in solitary confinement. When I do that, I have to see what is here with my x that needs to go. Well, there's a plus 7 there with the x that cannot be there in order for x to be alone. That's where, in order to undo or cancel out, I do the opposite. The opposite of plus 7 is minus 7. So I write right underneath it, minus 7. And the rule here is whatever I do to one side, I have to do to the other side. That means the other side of the equal sign, because I'm trying to keep a balance. So I'm also going to minus 7 over here. What did I do in this step? I said, well, I subtracted 7 from both sides. That is a very simple way to explain or justify the step of what's going on. And it's okay with me sometimes if you just put subtract 7 from both sides. But I want to do something called attend to precision. It means I want to make sure you know the proper vocabulary and ways to state the math. So here, when I go to my next one, I see here what I just modeled in the previous screen. Decide what needs to happen first. Well, I had to do the subtract 7. But here's the proper way to state that and the way you'll see in your paperwork. Since 7 is being added to x, Because you see here you have x and 7 is being added. Since 7 is being added to x, comma, then what we're going to do here is subtract 7 from both sides to undo the addition. Although in the last screen I just put subtract 7 from both sides, the more proper way to attend to precision is to say this. Since 7 is being added to x, subtract from 7 from both sides to undo the addition, because that's what we're doing. We're subtracting 7 from both sides to undo this plus 7 right here. So now when I do that, I have undone or canceled out those two 7s, and I'm left only with my variable x. And then now on the right hand side, I simply do the math. 9 minus 7 is 2. We already knew 2 is the answer from before, but this shows you with a very simple problem how to do a one-step equation and how to justify your answer. You're always going to say, since this is happening, then you're going to do that to undo. So third, you want to check your work. Here's my pop quiz on the spot. You should always check your solution in the original equation. Is that true or is that false? The answer is true. Go ahead and circle true. How would I check my work? Well, I would go back in and put 2 in for x and say, well, if the x is a 2, now it's not an unknown. I'm going to put 2 in. 2 plus 7 equals 9. Yes, that checks out. And so here's an example of how that worked. I put the 2 in for x. I said 2 plus 7 is 9. If 9 equals 9, which it does, you already know that your problem is complete. Now what I would like for you to do is to get a little bit of practice writing them out on your own. So in the textbook, the red textbook, you're going to go to page 17. And part A, not only are you going to read it, you're going to use in that space, literally just copying the work and the justifying. That's presentation station number 1 for solving simple equations.